Tropical cyclones are among nature's most powerful and awe-inspiring phenomena. They are immense, swirling storms that form over warm ocean waters and can unleash extraordinary wind, rain, and flooding across vast areas. Their formation, evolution, and eventual landfall have shaped coastlines, influenced cultures, and tested the resilience of human societies for centuries. Understanding how they form, what drives their intensity, and how they impact human life is critical for both scientists and communities living in vulnerable regions. The journey of a tropical cyclone begins over the expansive, sun-warmed oceans of the tropics. Here, the sun's relentless energy heats the water's surface, causing it to evaporate and fill the atmosphere above with warm, moist air. This moist air is lighter than the surrounding air and begins to rise, creating an area of lower pressure at the surface. As it rises, it cools and condenses, forming towering clouds and releasing latent heat. This heat further warms the surrounding air, causing it to rise more rapidly. The process becomes self-reinforcing. The more air that rises and condenses, the more heat is released, and the more intense the updraft becomes. But a crucial ingredient is needed for a tropical cyclone to take shape: the Coriolis effect. The Earth's rotation causes moving air to spiral, imparting the characteristic spin to these developing storms. Without this effect, the storm would not organize into the tight, rotating structure of a cyclone. That's why tropical cyclones never form right at the equator, where the Coriolis effect is weakest, but rather at least 5 degrees away from it. As the storm gathers strength, it may develop into a tropical depression. Winds increase, atmospheric pressure drops further, and the system becomes better organized. If conditions remain favorable, sea surface temperatures above 26.5 degrees Celsius, ample moisture in the mid-troposphere, and low vertical wind shear, the system intensifies. When sustained winds reach 39 miles per hour, it is classified as a tropical storm and given a name. If it continues to strengthen, reaching sustained winds of 74 miles per hour or more, it becomes a full-fledged tropical cyclone, a hurricane, typhoon, or cyclone, depending on the region. At the heart of a mature tropical cyclone lies the eye, a relatively calm, clear area surrounded by the eye wall, where the most violent winds and heaviest rains are found. The eye typically measures 20 to 40 miles across and is a striking example of order within chaos. Encircling the eye wall contains thunderstorms that can reach heights of 50,000 feet, with winds that can exceed 150 miles per hour in the most intense storms. The structure of a tropical cyclone is a marvel of atmospheric dynamics. Spiral bands of thunderstorms sweep outward from the center, bringing rain and gusty winds far from the storm's core. These bands can stretch for hundreds of miles, ensuring that the impact of a cyclone is felt well beyond the immediate vicinity of its center. The life cycle of a tropical cyclone is shaped by its environment. It draws energy from warm ocean water, so as long as it remains over the sea and the conditions are right, it can continue to grow. But when it moves over cooler waters or encounters land, it is cut off from its energy source. Friction with the land surface, a lack of moisture, and increased wind shear weaken the storm, eventually causing it to dissipate. Despite their beauty and the fascination they inspire, tropical cyclones are among the most destructive natural hazards on Earth. Their impact on human life is profound and multifaceted, affecting millions of people each year. When a tropical cyclone approaches land, its strong winds can tear apart buildings, uproot trees, and flatten entire communities. The force of the wind alone can snap power lines, collapse bridges, and turn ordinary objects into dangerous missiles. But wind is only part of the threat. Perhaps the most deadly aspect of tropical cyclones is the storm surge, a dome of seawater pushed ashore by the storm's fierce winds. Storm surge can inundate coastal areas, flooding homes, roads, and infrastructure. In low-lying regions, the surge can reach heights of over 20 feet, overwhelming seawalls and flood defenses. This sudden rise in water levels is often responsible for the greatest number of fatalities during a cyclone, as it can sweep people, vehicles, and entire buildings away in minutes. Heavy rainfall is another hallmark of tropical cyclones. These storms can unleash vast quantities of rain over short periods, leading to flash flooding, landslides, and the overflowing of rivers and streams. In mountainous or hilly terrain, the risk of landslides and mudflows increases dramatically, threatening communities far from the coast. In the aftermath of a cyclone, the effects on human life can be devastating. Homes may be destroyed, leaving families without shelter. Crops and livestock can be wiped out, threatening food security and livelihoods. Essential services such as electricity, water, and communications may be disrupted for days or weeks, hindering rescue and recovery efforts. Health risks rise as clean water becomes scarce, sanitation systems fail, and disease spreads in crowded shelters. Yet, the impact of tropical cyclones is not felt equally by all. Vulnerability depends on a region's geography, infrastructure, preparedness, and socioeconomic status. Developing countries often bear the brunt of cyclone damage, as limited resources can hamper efforts to build resilient infrastructure or mount effective evacuations. Coastal megacities with their dense populations and sprawling slums are particularly at risk. Despite the challenges, human societies have developed strategies to mitigate the impact of tropical cyclones. Early warning systems, based on satellite observations and sophisticated forecasting models, provide advance notice of approaching storms, enabling governments to issue evacuation orders and mobilize emergency services. Building codes and land use planning can reduce exposure to the most hazardous areas, while investments in seawalls, levees, and drainage systems help defend critical infrastructure. Community education and preparedness are vital. Teaching people how to prepare for a storm, where to evacuate, and how to stay safe during and after a cyclone can save countless lives. International cooperation, humanitarian aid, and disaster response teams play a crucial role in helping affected regions recover and rebuild. Tropical cyclones also have important ecological effects. While their destructive power can be overwhelming, they are part of the Earth's natural systems. Cyclones help to regulate the global heat balance, moving warm air and water from the tropics toward the poles. Their rains can break droughts, replenish groundwater, and sustain wetlands and forests. In some cases, the disturbance caused by a cyclone can even help certain ecosystems to rejuvenate and adapt. However, the relationship between tropical cyclones and the changing climate is an area of active research and concern. Warmer ocean temperatures, rising sea levels, and shifting atmospheric patterns may influence the frequency, intensity, and track of future storms. There is evidence that the most intense cyclones, those with the greatest potential for catastrophic damage, are becoming more common as the climate warms. Higher sea levels mean that storm surges can reach further inland, increasing the risk of flooding in coastal cities. Understanding these trends and preparing for a future in which cyclones may pose even greater risks is a major challenge for scientists, policymakers, and communities alike. The history of tropical cyclones is filled with stories of tragedy and resilience. The 1970 Pola cyclone in Bangladesh, for example, claimed hundreds of thousands of lives in a single night, spurring the development of one of the world's most effective cyclone warning and shelter systems. Hurricane Katrina in 2005 exposed the vulnerabilities of a major American city and led to sweeping changes in disaster response and urban planning. Typhoon Haiyan, which struck the Philippines in 2013, galvanized international aid efforts and highlighted the need for global solidarity in the face of natural disasters. In every case, the lessons learned from past cyclones have driven improvements in forecasting, preparedness, and response. Advances in satellite technology, computer modeling, and communication networks have made it possible to track storms with unprecedented accuracy and provide early warnings to those in harm's way. Scientists continue to study the complex dynamics of cyclone formation and evolution, seeking to unlock the secrets of these mighty storms and reduce their toll on human life. For individuals and families living in cyclone-prone regions, preparation is key. Knowing the risks, having a plan, and staying informed can make the difference between safety and disaster. Emergency kits with food, water, medicine, and essential supplies should be ready before cyclone season begins. Understanding evacuation routes, identifying safe shelters, and keeping important documents secure are vital steps. During a storm, following official advice, seeking shelter in sturdy buildings, and avoiding floodwaters can save lives. In the broader sense, resilience to tropical cyclones is built over time through investments in infrastructure, education, and social support systems. Strong communities, with networks of neighbors and local organizations, are better able to withstand and recover from the shocks of a major storm. Governments, businesses, and civil society must work together to reduce risks, protect the most vulnerable, and ensure that recovery efforts are swift and equitable. Tropical cyclones are a reminder of the power and unpredictability of nature. Their formation is a testament to the incredible complexity of the Earth's atmosphere and oceans, while their impact on human life reflects our ongoing struggle to live in harmony with the natural world. As the climate changes and populations grow along vulnerable coastlines, the challenge of coexisting with tropical cyclones will only become more urgent. Yet, there is hope. Through science, innovation, and cooperation, we have the tools to forecast, prepare for, and recover from these storms. By learning from the past, investing in the future, and building resilient communities, we can reduce the human cost of tropical cyclones and ensure that, even in the face of nature's fury, people can survive, recover, and thrive. As we look to the future, the story of tropical cyclones is still being written. With each storm, we gain new insights into the workings of our planet and the resilience of the human spirit. By respecting the power of these storms and preparing for their inevitable arrival, we can protect lives, preserve livelihoods, and build a safer, more sustainable world for generations to come. From the first whisper of a disturbance over distant, sunlit seas, to the roar of the wind and the rush of floodwaters on distant shores, tropical cyclones remind us of the interconnectedness of the Earth's systems and the profound impact of weather on human history. They are both destroyers and creators, shaping landscapes, testing societies, and inspiring awe at the forces that govern our world. In understanding the formation and impact of tropical cyclones, we come face to face with the challenges and opportunities of living on a dynamic, ever-changing planet. It is a story of science, adaptation, and the enduring quest to find security in a world where the winds and waters are always in motion.